So I will be talking about how a DCC system works. So I have conventional DC. They're similar in different ways. Just regular DC, you just apply power and it goes depending on the direction you select. Well, basically changing the way the voltage travels. So DCC will run off 16 volts of AC current, which is way different than DC, which also means we can't run them together, because like if I were to use AC power, this would actually damage the motors in here, which is kind of hidden, but it basically would damage the motor, because basically it would try to turn but it couldn't turn, because that's what the decoder also does, is it helps kind of convert it over a little bit, and it also kind of gives it the signals it needs. So the decoders, basically it's a little circuit depending on the one. Some of them have sound, some don't. They will allow you to, they basically pick up a signal from a specific address. So for example, if this were to be DCC, it would be 308. And then this also depends on what you set the address to. It's traditionally road numbered, but not always. So then, depending on the current, all really depends on your power packs. So just like DC, yeah, each power pack's a little different in voltage. This is a 16, and this one's actually a 12 volt. So two very similar power packs with two different voltages. Ampage, usually for DC, I mean, this is a little bit older. They don't say it on there, but probably about 1.5 for those. But the DCC ones can handle, depending on the size of them and what they're rated for, you can go up to 10 amps, which, I mean, 2 is about 25-ish locomotives. So, I mean, that's a decent sized layout for sure. Do you need that much ampage and current just to get it through? I mean, plus you'd also have like boosters and stuff throughout the layout just to keep the current going. And also, you know, not so much strain on the power. Well, and the resistance is obviously going to vary on what you have running. So, I mean, this actually, because this is leaded, and it's technically this one is somewhat leaded, that'll be some resistance, not as much as obviously the locomotive, which these two don't have working headlights right now. That will draw a lot more of the current, because obviously you got to turn a motor on both of them, and then the Centennial, which that's just sitting there. And the reason why this one doesn't move on either power pack is because I have block systems. DCC, on the other hand, will never need that, because it's constant AC power, and then, like I stated earlier, the decoder would pick up a certain address, which is only linked to that, which tells it to which direction to move. So it basically sends a signal saying, hey, I need you to move forward. It'll move forward. I need you to go to reverse. And then also some of the other features, if it has sound, technically, I forgot to shut off the main line there. Like that one also has a blinking beacon and stuff. On DCC, you'd actually be able to control that along with the headlights. So there's a lot more features involved. So you don't have to have like every headlight running. Like this will just run constant. But that also, like with the decoders and stuff, you can, yes, still run them on a conventional DC. It isn't the greatest for them, because it's basically trying to pick up a signal, but then the DC is trying to override it, basically, and they don't like each other too well. But if you were to run a DC locomotive on DCC, well, you're basically killing the motor, because it'll try to run, and I'm not going to demonstrate that, Even if I wanted, could, I wouldn't, because that can fry the motors completely, and that's something you don't want. But basically, depending on the power packs, because some of them do look like a DC one, but usually they'll have number pads on them for typing in the codes and addresses, and then some of them, like, you'll just have like a box basically, which, besides boosters, because you typically have boosters, you have a bus line or two going through, basically trying just to keep electricity moving throughout the layout into different sections that you need it, so your train isn't like all of a sudden slowing down ridiculously because it doesn't have enough current going through. And I mean, obviously you don't want, like, because if I put like let's see how many I can do. The more locomotives I were to put out and stuff, like if I were to, for instance, put, because this is DC, I would actually need more electricity just to go through, just to get both of these to move. So DCC, on the other hand, it will. There's some of the more high-tech ones. They have a feature where you can set up like a consist, which that means, well, they can communicate together. So basically, both of them will kind of use to pick up the voltage that they need to and tell the motor to go at the same speed. So even if they're synced differently, they'll actually be able to work together and basically pick up the voltage that they need in order to be at that speed, so they're not like bashing each other and making the train kind of messed up, and they're not straining one and one's like basically doing all the work, or both are struggling because they're really behind. But anyways, with that, hope you guys learned something about how a DCC system works.